Faraday's law of electricity. As per the introduction, Faraday's law of electromagnetic induction is also known as Faraday's law. It is the basic law of electromagnetism which help us to predict how a magnetic field will interact with an electric circuit to produce an electromotive force that is called EMF. Faraday's first law of electromagnetic induction. The phenomena is known as electromagnetic induction, proposed by Michael Faraday in the year 1831. Whenever a conductor placed in a varying magnetic field, an electromotive force is induced. If the conductor circuit is closed, the current is induced, which is called induced current. The Faraday's second law of electromagnetic induction. Faraday's second law of electromagnetic induction states that the induced EMF in a coil is equal to the rate of change of flux linkages. Flux linkages is the product of number of turns in the coil. Therefore, E is equal to minus n phi by T. There is another law called Lenz's law of electricity. Here Lenz's law is very important in respect of Faraday's law of electricity. Lenz's law states that the polarity of induced EMF tends to produce a current which opposes the change in magnetic flux that produce it. Thus, the direction of the induced EMF opposes the direction of the magnetic field which is produced. Consider a magnet approaching a coil two times, that is T1 and T2. Therefore, the flux linkage with coil T1 is N phi 1. Flux linkage with coil at time T2 is equal to N phi 2. The change in flux linkage is equal to N phi 2 minus phi 1. Therefore, phi 2 is equal to phi is equal to phi 2 minus phi 1 is the change in flux. Therefore, change in flux linkage is N phi. The change of flux linkage is given as N d phi by dt. The induced EMF in the coil is equal to the rate of change of flux linkages. Considering Lenz's law, the induced EMF in the coil is equal to E is equal to N d phi by dt. Thank you for watching. Feel free to ask any question in the comments below. Please do not forget to like and subscribe. Thank you.